Hey boys and girls and parents, here's a review of the first chapter. And that chapter is all about patterns and shapes and numbers, and this is for grades 4 and grade 5s. First of all, let's talk about patterns with one attribute. Attribute is something that changes. So in this basic pattern here, there's only one thing changing. The color's not changing. What's changing? The shape is changing. So what's changing? It's a shape. So this says square, square, circle, circle, circle. Square, square, circle, circle, circle. So what would come next? We need square, square, and then 3 more circles, etc., etc. But when you have a pattern with 2 attributes, this can be much more confusing. 2 things are changing in this pattern. In one way, we have the changing, the color is changing. And secondly, we have the shape changing. So I like to kind of work on top and underneath the pattern. On top, I'm just going to look at the color. So let's call this gray. Gray, gray, white, white. Gray, gray, white, white. Gray, gray, white, white. So whatever comes next, I'm going to need a gray one, a white one, and a white one. So I just isolated for color that time. Now I'm going to do shape. Square, square, circle. So square, square, circle. 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 So I need a gray square inside here. When I add the numbers on top and the bottom, I can start filling in what the shapes are. I need gray, gray, white, white, gray, gray, white, white, gray. On the bottom, I need square, square, circle, square, square, circle, square, square, circle. That should be like that. So when you're doing a pattern like this, it's good to isolate one attribute on top and one on the bottom, and then just try to extend it after that. Now, here's another example down here. Again, I'm just going to do shape. Square, 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 circle. Square, 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 circle. Square, 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 circle. Square, 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 circle. So I need a square, I need a square, I need a square, and then a circle. I usually do all the shape first, and then I worry about the color later. So it's white, gray, black. White, gray, black. White, gray, black. White, gray, black. White, gray, black, and then white. So that's what the next patterns would look like. Now let's take a look at patterns that might be in numbers. How do you figure out what number comes next? This is a nice, what I usually do when I attack a pattern like this, I really look at what the difference is between the numbers. So the difference between 3 and 5 is I've added 3. Each time you've added 3 in between, so this is a pattern that adds 3. So that means I would have 14, and I would have 17, etc., etc. here. How do you describe the pattern? You always start with what it starts with. So I'd write at 2, then add 3 each time. This kind of pattern, you have the same amount adding each time. Let's take a look down here. Difference of 1, then difference of 2, then difference of 3, difference of 4, difference of 5. Oh, 5. So that would mean difference of 6 would come here. And that means I'd have 22. 22. Then a difference of 7, that means 29, etc., etc. So this pattern, again, start at 1, add 1, then 2, then 3, and then etc. Keep going. Start at 1, add 1, then 2, then 3, so on and so on. Let's talk about this pattern here. The difference is 9, the difference is 8, the difference is 7, and it's going down. So I need a difference of 6 here. That would mean 69, then a difference of 5, that would be 64. So to describe this pattern, I would say start at 99, subtract 9, then subtract 8, etc. So that's how you do that one. Now let's take a look at this. This is mostly about working with tables. Sometimes in patterns though, we can make diagrams. And we do a diagram like this. There is some merit in doing that, and that is helpful. After a while though, the diagram gets so large that it's a little easier to go to a table. Let's just take a look at the fourth design here. When I take a look at a design like this, I try to figure out what's added. Where are they adding things to? And in something like this, I try to just look at one part at a time. Let's just talk about the top of the T here. First, I've got 1 in the top, then I've got 3 in the top, then I've got 5 in the top, 1, 3, 5. I need to have 7 in the top here. 1, 2, 3, 4, 5, 6, 7. So now I'm going to look at the tail here. I've got nothing in the tail, I've got 2 in the tail, I've got 4 in the tail, now I need 6 in the tail. 1, 2, 3, 4, 5, 6. So I've got 7 up here, 6 over there, that's going to be 13. So I've got 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I've got 13 over here. So I change over to a table now. Because it's going to get larger and larger, it's going to be harder to draw. In the first term, or the first design, I had 1, then I had 5, then I had 9, then I had 13, and I notice I'm adding 4 each time, which makes sense because I add 1 on the end, 1 on the end, and I add 2 on the tail each time. So if I add 4 here, I'm going to get 17 and 21 and 25 and 29 if I've done that correctly. Okay? So drawing one more shape is okay, but when you have to do larger shapes, it's better to stop the drawing and turn it into a table, and the table kind of helps you out. Now, here's also a recipe that came up a lot in our work. Again, a table for a recipe. Usually here's a recipe for a number of servings, or like here's the recipe at 1 time, but sometimes we have to double the recipe or triple or so and so. But again, we just 2 plus 2 is 4, plus 2 is 6, 8, and 10, 250 mils, 500 mils, 750 mils, 1,000 mils, and then 1,250 mils. And this half plus a half is 1 cup. Then I have 1½ cups. Then I have 2 cups. Then I have 2½ cups. Now we haven't really added fractions, but that basic adding I'm hoping you're going to be able to do. Okay, let's keep going. Oh, by the way, the bottom was just for grade 5s. So grade 5s, tables like that with recipes, that was in your work, but it wasn't in the grade 4's work. Again, here's a grade 5 only, so grade 4s can take a little nap. There was a section in the textbook where they tried to teach us to solve problems by looking at a pattern, and this is a pattern that they use where you've got a series of regular numbers, and what they want you to do is to add this by looking for a pattern. The pattern they want you to do is take the smallest guy and add it to the biggest guy, and for us, that's going to be 90. Okay, so that's 90, and this guy is 90, and this guy is 90, and these two guys all up to 90. So every pair here is 90. So the answer for this, adding all of it, is really 90 times the number of pairs. So I know there's 1, 2, 3, 4 pairs in this one. The other way to figure it out is there are 8 numbers altogether because it's like a regular pattern, and there's 8 numbers. The number of pairs will be half of 8, which ends up being 4. So 90 times 4, with a calculator I can figure out that that's 360. So all these together add up to 360. So instead of adding them all individually with my head or on paper or with a calculator, I can just look for the pairs and do it here. Here's another one here. This is 1 and this is 10. So the biggest and the smallest add up to 11, And now I have to figure out how many pairs there are. Well, I know there's 10 rows of cans. So 10 rows of cans, half of that will equal 5 pairs. So 11 times 5 gives me 55. So very quickly in this kind of thing, by taking the biggest and the smallest and figure out how many pairs there are, I will figure out that this is 55. Okay, grade 4, it's your turn. Figuring out the missing numbers using expressions, or the other word for expressions is equations. So in this one, I'm looking at the pattern, 44 plus 3 plus 3. So this is a plus 3 pattern. So I don't know, I see the pattern is adding by 3, but I don't know what this mystery box is. So I'm going to make an equation. If you don't mind, I'm going to write it all out over here. I'm at 50. I know I'm adding by 3, and so that will give me the number that's in the box, and that gives me a number of 53. You can also do a subtraction equation. For an adding equation, you go before the box, but for a subtraction equation, you go after the box. So for after the box, it's 56. Well, I know it's a pattern of 3s this time. Instead of adding 3 to get to 56, I'm going to take 3 away, and that will also give me my total of 53. So if you come up with a mystery box and it's a regular pattern, you can add that amount to the number before to get the number, or you can also subtract it. So that's a kind of an introduction to equations as well. Okay, I think this is the last page. Now we're going to talk about, again, grade 4, we're going to talk about equivalent equations. What equals means is that this is the same as that. Equals doesn't mean add or subtract. It means the one side is the same as the other side, and that's what this box talks about. So if you've got 11 plus 2, we know that's 13. So these shapes have to also add up to 13. So let's just start off with some easy ones. The square could be, let's say the square is here, and the circle is here. So the square could be 1. And that would mean that the circle would have to be 12 to add up to 13. The square could be 2. The circle would have to be 11. The square could be 3. The circle could add up to 10. The square could be 4. The circle could add up to 9, etc., etc. And there's more combinations of that. Okay. Now our last grade 5 problem. Again, very similar to the recipe problem. They're going to ask you to fill in a table. One team needs 15 players, 2 coaches, and 4 soccer balls. So 2 teams, 3 teams, 4 teams, 15, 30, 45, 60, because that's counting by 15s. This is 2, 4, 6, 8. And number of balls is 4, 8, 12, and 16. So usually they ask you to add a table, but then they'll ask you, well, if you have 100 players, how many teams can you make? Really, for something like this, I don't really care about, it doesn't ask me about coaches, doesn't ask me balls, but it does ask me about players. One way to do this is just keep going. 5 teams will make 75. I'm not there yet. 6 teams will make, I need 90 players. And 7 teams will give me 105 players. I only have 100 players. So how many teams can I make? Well, I can't really make 7 full teams the way it's written here. So my answer will be I can make 6 teams, but I'm going to have 10 players left over. So that would be a suitable answer for that. If I have 100 players, how many teams can I make? I can make 6 full teams, plus I've got 10 players left over. Okay? So that is a review of some of the concepts that are in Chapter 1 for grade 4 and 5. And I hope that's helpful. Good luck on the big test. Talk to you later. Bye-bye.